let's review some of the operations we can perform in coding and see how they're done in Python. Good news, pretty straightforward. First, we have our mathematical operators that allow us to do some basic math calculations. Adding, subtracting, multiplying, dividing, exponentiation or exponents, and the modulo. The last one being probably the trickiest to understand. I'm going to define a couple simple variables here. I'm going to state a as 3 and b as 4. Just to review last lesson, we don't have to state the type of the variable. It's automatically interpreted as being an integer, so these are both considered integers. And down below here, I'm just going to print some result of a and operating alongside b. So a plus b. If I run this program, I see 7 being the result as expected. Same thing for subtract. Oops, I started debugging by accident. Let's go back here and just run this. -1, 3 minus 4, perfect. Then we have the multiply, 3 times 4 is 12, and the division. Now, if you're used to Java, you might expect something strange to happen here, but in Python, we get the exact value. Even though both of these values are integers, the result is expressed as a double. Because Python knows, well, there's actually a decimal value to the result, so you know what? We're just going to express that decimal value despite these both being integers, so the result is actually a float. Technically, there is another operator here, which is called I think it's called base division. I believe is the formal name for it. And what this allows us to do is perform the actual integer division, which rounds the final answer. So 3 divided by 4 is 0.75, but it rounds down. So if I made this 5 divided by 4 and ran this, the base division will round it down to 1. But if I want the actual full division, 1.25 would be the answer for this. So technically that is an option, although it's not super useful in too many cases. I'm also able to raise one of the numbers to the power of the other. In this case, 5 to the power of 4 is 625. So we have the exponentiation going on. And the final one we want to look at here is the modulo, a percentage b. And the answer to this first scenario is 1, which is strange. We did cover the modulo last year, but here's a quick recap for us. Modulo is all about the remainder. And what I'm looking at here is the number of 5. How many times does it go into the number of 4? But I don't care about how many times it goes in. I'm caring about the remainder of that division. So 5 goes into 4 once with a single value left over. 6, on the other hand, goes into 4 once with 2 left over. 7 with 3 left over. And 8 would have no remainder because it goes in evenly. There's no remainder left over. How about smaller numbers, like 1 going into 4? Well, the entire value is the remainder. Same with 2, same with 3. 4 itself is divisible. There's no remainder. So this is simply popping out the remainder left over after that whole number division concludes. And I highly recommend that if you're at all confused about how the modulo works, to read some extra documentation about it and just do a whole bunch of tests in your code to see if you can't develop an intuition for exactly how this mathematical operator actually works. Cool, so those are our math operators, pretty straightforward. Now let's head down here, some space down below here for our relational operators, the things that allow us to relate one thing to another. So let me just pull this a and b down so we don't have repeated information. A is, in this case, let's just make it 5, and why don't we make this 5 and 3 this time around? And now we're able to actually see how things relate to one another. Just to check how this works, I'm going to have a print call that's going to check the relationship, and it's going to print out true or false, whether or not the outcome of this is true or false. So first of all, does A equal B in this scenario? Hopefully, you can answer this for yourself. The answer is false. Does A not equal B? True. A does not equal B. What I'm doing here is examining the two different values. A is not equal to B. They're not equal. So the result of that comparator, that operation, is true. I don't have to just check for equality or lack of equality, however. I can also look at the relative values being greater than or less than or greater than equal to or less than equal to. Is A greater than B? Yes, it is. Is it less than B? No, it's not. And same thing for greater than equals to, less than equals to. I'm sure you can figure these things out. We've done it lots of times before in our coding. So we have these relational operators that allow us to compare values to one another. And just for curiosity's sake, something to explore a little bit in advance, we're going to cover this in a future section in the course, but what if I made A the word apple and B, the word zoo. And then I compared these strings to one another. Interesting. Is A greater than or equal to B? It says false. Is it less than or equal to B? True. So technically, somehow, this string apple is less than the string zoo. Is A equal? Well, this is maybe a bit more logical. It is not. It's definitely not equal to. But what if I had the word apple appear twice? Does this check for equality? It actually does. So I can actually compare strings to one another with these relational operators in a similar way. Just know that the greater than or less than kind of aspect of this has a little bit more nuance to it that we'll cover in a later section. But feel free to look it up if you're curious to learn more about it now. There's technically one other type of operator, but we're going to save that for the next lesson where we move into conditional logic.